Swayam Prabha. Digital India. Educated India.
Hello, Namaste. Welcome back to the course on Geographic Information System. In this particular module, we would be looking at geographic systems as I spoke in my first lecture, where in this particular lecture I would look at elevation referencing, relative referencing and discrete referencing in detail. And I would also, this is extremely important when you are actually looking at any of your georeferencing system. So please be careful in understanding each and every aspect of it. I would also suggest once you have seen this particular lecture, please read some of the materials that may be available online, or there are very good books on GIS which I have also already referred in my first introductory lecture. Please read some of those books so that you are sure on what you have learned. So that is this part is very important in terms of when you are looking at to become a GIS expert. Okay, so in today's session we would look at first elevation georeferencing, the relative georeferencing, then we would look at polar. So polar is a continuous kind of georeferencing. Then we would look at discrete georeferencing system. Then we would look at decoding the mailing address. So that is also very important in terms of how a particular post or a parcel reaches us without even putting the entire address maybe in your envelope. For example, if I just say my name with the Indian Institute of Technology Kharagpur and 721303, it reaches with me without any hassle. So that means to say that the entire mailing address has certain way of looking at it. So we'll look at that. So just to go back to the previous so that we understand it much better, the first we started with what is georeferencing. We have two types of georeferencing we looked at. One is continuous georeferencing, other one is the discrete georeferencing. When we look at the continuous system, we have relative georeferencing, other one is a direct georeferencing. When I look at relative georeferencing, we have polar coordinate referencing, whereas we look at the direct georeferencing, then we have elevation referencing, datums, coordinate systems and map projections. This is what we would look at in the next 2-3 classes of this particular subject. Then we looked at discrete referencing. We also said how discrete referencing can be done. So this is what we learnt in our first lecture on this particular topic. Now let's go into each and every of the kind of this referencing and look at why it is important and how do we look at it. The first kind of referencing is elevation referencing. So for when we always consider any of the vertical referencing system, the 0 point from an altitude system is based on the mean sea level. So when I say mean sea level, you have 0 as a reference point, that means sea level is 0 altitude. So based on that you start to look at the vertical space. So that means this mean sea level is always a referencing point. So this area which through all the points at a 0 altitude is called as a geoid. Okay, please keep this in mind. This particular area which through all the points of the 0 altitude of the earth's surface is called as a geoid. Geoid is nothing but a 0 altitude. We can even look at geoid in a better way. I'll explain it to you in the next slide. 0 point for elevation references is based on measurement of variations in the oceanic surface. So that you should keep in mind. So it is not just about saying that this is the mean sea level, but you have to look at every references in terms of the oceanic surface, and based on that relatively you look at the 0 point. Okay, so when I come to the geoid is affected by mass of earth. So there are lot of variations that you can see, the geoid that you are measuring at one place to the geoid that you are measuring on the other place, okay, or the mean sea level, zero mean sea level that you are measuring on one place and the zero mean sea level that you are measuring on the other place. So geoid is affected by the mass of earth and therefore follows the earth contours. I spoke about what is a contour in my previous class. So it follows the earth contours upward at the mountains, okay. So the way the contours flow, the upward direction, it also flows upward at the mountains where there is large amount of land mass, and downward where there is a less land mass, okay. So we have to understand this very clearly. So it is the way the earth contours move. If it is a mountain, it moves like this. Then suddenly if there is a system where you have lower references, or you have a downward trend in the earth's surface, it moves like this. That's nothing but a geoid. Geoid can be also defined. So it is normally geoid is your thinking, okay. Geoid can be defined as a very hypothetical surface. It's an hypothetical surface of the earth that is actually formed from the mean sea level and is in a continuation through the continents at the same level of the gravitational potential. So now you should understand that gravitational potential also is involved in terms of defining a geoid, okay. So it is a continuous as the earth's surface follows the contours and represents the entire mean sea level, but maintains the same level of the gravitational force. So look at the every aspect of it. And one thing that you should remember is that geoid will never coincide with the rotational ellipsoid, okay. So if otherwise it's not called a geoid, okay. So to give you an example of a geoid, on your right hand side image that is from one of the sources here that's mentioned, you can see this is a geoid of the earth's surface, okay. If you can see, this is the earth's surface, it is a spheroid. So geoid is something like this, okay. So you can see wherever there is higher land mass, you can see it is, okay, where there is actually it is going down, you could see some changes here, okay. So it is where you have a zero mean sea level. So this is the first concept that you have to understand. Then the second one is relative georeferencing. So relative georeferencing is also a continuous georeferencing. When you look at relative georeferencing, it includes polar coordinates, offset distance, measurement along a road network. So I will get into each of these aspects in my next slides. The first aspect is polar georeferencing. It is also called as an indirect georeferencing. I spoke about polar in my previous class. So it is basically an indirect georeferencing. What we do is that we consider we do the measurements of a distance in relation to a reference point and the direction in relation to an axis, that is usually north axis. If we look at this particular image, okay, if we look, this is if we have considered, if this is a north pole, okay, if that is a north pole that we have considered, and this is the Polaris, okay, with now if we have to measure a particular point here with reference to this, what is a distance, then with reference to this, what is the angle that it is making. If you have an imaginary line, so what is the angle that it is making is calculated. That is nothing but a polar georeferencing. That's how you reference that this point on the earth's surface with respect to the north direction lies somewhere here, okay. So that's how you do a polar georeferencing, okay. Now next thing is offset distance. So this is also a kind of a continuous georeferencing, where offset distance methods will specify the location with either direction and the distance, or only distances from the or only distances from a specific object on the terrain. So if for example, if you are looking at a pipeline, okay, now these are the objects on the earth's surface, okay. Now this offset distance method will specify the location of this particular pipeline based on these objects on the earth's surface, okay, without which you will not be able to get a particular location. Location of a point can be expressed as a distance from a physical object in a terrain. It's always a distance. If many of times it is only distances that is mentioned, but in case there are certain systems where you can even look at even the directions. Then you have road network, but this particular kind of measurement is actually an approximate way of looking at your referencing. So when you are looking at a road network, the referencing system is often based on measurement of a distance from a given intersection. So keep this in mind, you are always measuring from an intersection. This will give only the principal topology of a particular network, but it doesn't really give you the direction and the displacement in that particular network, okay. A road network can therefore be presented only schematically, okay. It can only be presented schematically. One example is shown on the right hand side, which is actually representing one of the very prominent regions in Kolkata, okay. The third when we look at relative georeferencing, there are huge number of disadvantages. Some of them are when we it's quite unstable. When we look at relative georeferencing, is quite unstable and vulnerable, since the reference terrain are linked to the physical objects. So whether it is road, whether it is objects on the earth's surface that we are trying to look at, so these physical objects are linked. When you are looking at distance or direction, the physical objects are taken into consideration, which actually if there is a change in this physical objects, then your direction and your dimension changes on your earth surface. Once the object is removed or moved, the referencing system also is changed. So that's what I meant. Then rerouting or straightening of roads, if certain things happens like that, then the way you have georeference, your old map may not fit into the new map. So then as a discrete georeferencing system. In this system, the positions of phenomena are measured relative to fixed limited units of the surface of the earth, okay. Please be careful in this. In this system, the positions of a phenomena, okay, are measured relative to fixed. You are relatively measuring, okay, limited units of the surface of the earth. The system helps us to know the object is located within the specified reference unit, but when you are looking at the location within the reference unit, it is unknown. This is what is the problem of discrete referencing. So it helps you to locate an object within a specified reference unit, but if the location within the reference unit is quite unknown. If you are taking this, there is one building, or let us say one parcel as a reference unit, within that reference unit the whatever position is unknown, but with reference to that reference unit, around the positions is quite known. So that is one disadvantage of this particular system. Then the objects are linked to geography using reference units called as tags. So that is what I meant. The tags or units is nothing but the discrete referencing system. It's also called as a tagging method. Discrete referencing system, discrete method or a tagging method. Street addresses or mailing addresses are often used as simplified georeferencing systems. So this is the best and the easiest way of georeferencing. So everyone at every nook and corner can understand this kind of georeferencing. So when you look at discrete georeferencing, for example, if you are georeferencing your mailing address, is also called as a geocoding. You are coding your point on the earth surface using a mailing address. So it's called geocoding, okay. For example, if I have something like this, there is a sample mailing address that is shown here. When you see this is a sample mailing address. It's Sports India Limited. You have a ground floor, okay. This is all the attribute information that you have. But when you look at Salt Lake Electronic Complex, that is where a particular position is there. But what that is actually referring is, it is in 73091, So which means that it is in Kolkata, in Bidan Nagar, in a Salt Lake City. So that's already, now it is giving, it's pinpointing you to a particular location, a small area in Kolkata. So once you have known that particular, and it says this particular pin code belongs to sector 5. So now you know where sector 5 is. So now it is much more smaller region. Now just with the block information and then the name of that particular building, you know where you have to deliver your post or your parcel. So that is what, that is nothing but a geocoding. Okay. So mailing address may vary from country to country, always it varies. Okay. So mailing addresses is one of the most common technique for using a geocoding issues. Okay. So please remember this, whenever we have to use any kind of georeferencing in terms of discrete georeferencing, most of the best methods used is in the form of a geocoding, and they use nothing but a mailing system. Then when we look at this kind of system, it is a hierarchy of geographic identifiers that become more specific as you proceed from bottom to top of the address list. Okay. For example, when I am looking at here, the first thing that anywhere, for example, there is a parcel that is actually coming from maybe some part of Switzerland to India. Okay. So now the first thing is India. Okay. So now that then is 70091. So now you are actually digging information from a country to a region. Now with a region, you know which city, right? Which city and which place in that particular city. Bidan Nagar is another place. So now in that Bidan Nagar, okay, Bidan Nagar area, so you have a Salt Lake City. So Salt Lake City is then looked at. Then it is sector 5. Okay, this particular pin code belongs to sector 5. So that is the first thing. Then the digging will happen with the block, the EP block. It belongs to EP block. So then is your Sports India Limited. So that is what is called as a hierarchy. Always that discrete referencing system is in terms of a hierarchy. So it proceeds from bottom to top of the address. So the first address is looked at from the bottom. Then mail is progressively sorted in that order until it gets placed in a specific order that the postal carrier delivers it. Okay. So when we look at geocoding systems, use information in an address to assign it to various geographic features. So please be careful, we are assigning it to various geographic features. That's how mailing address will become into a geographic address. Okay. So when we look at one example here, we have a typical mailing address in a reverse order. So from the least specific to the most specific. That gives you the hierarchy how it actually follows. For example, when I am considering this here, the first thing is the first thing that we normally see is India and a country, right? So once we have seen that, then the next point is we will look at it is in the state of West Bengal, right? So then we look at the 6-digit pin code, then is the city, then is the area, then is the sub area, that is the Salt Lake City, then we look at the sector, then at block, then look at the building, and then the floor name. So now we are indirectly actually looking at different hierarchies here. So if you look at the final thing is the name of the business. So for example, if you are trying to mail me, if it is if this is my mailing address, for example, if you just write this, okay, IIT Kharagpur and 721300302, the first thing that we see here is 7213002. Then the IIT Kharagpur is the location where it has to reach, then is the department, then is the person's name where it has to be delivered. So that is how this discrete referencing system works. Okay. Now, three major categories by which the discrete referencing system can be done is one is a postal code and area names that I have explained in my previous slide. Even you can look at discrete referencing system using administrative zones and statistical unit. Normally, in terms of if you see the government gazetteers, you will find out all this. The grids and the map sheet. This we learn when we are looking at what is a map and what are the different qualities, quantities in a map. Okay. So when we look at discrete referencing system, it is if you see this, ward number, postal code and area name. These are certain examples. For example, I have shown here the entire Kolkata city. Okay, when you look at the entire Kolkata city, here you can see that these are the ones. For there is 70052 to 7006394. All of these are representations of the pin code of that particular city. Now we have wards, different wards in the entire city. If you see here, the number of the ward number also represents a particular geocoding of that particular place. Then you have postal codes I have spoke, and these area names, for example the Tangra, the Gobra, and you have Raja Bazar. So all of these, or the Salt Lake area, so all of these are nothing but a geocoding into your map. So you are giving a referencing way. So that referencing way may be understood by many. If I say Salt Lake City in Kolkata, many of them will understand this particular place is somewhere here. Okay. So if I say there is an DC block, or maybe a CD block or EF block, so they will understand in the Salt Lake City there are certain blocks, and EF blocks can be reached by this point. So that is nothing but your coding your earth information or information about objects in terms of the area name, and or you can even say it as a ward name. Ward name is not easily seen. For example, no one can understand that if you say that I belong to ward number 100. Okay, because it's extremely difficult to remember if a city has 198 or 200 or 500 wards. So it is extremely difficult for them to understand or remember all of these names. Instead, it is much easier to remember in terms of the area names. Okay, so yeah, that is about looking at the discrete referencing system. So the next thing that we would also look at here is okay, this is an example of an administrative zones and statistical units. That's also a discrete referencing system. So now, for example, there are two images that you can see here. One image is in the form of your boundary here in the purple color. So this particular boundary is representing a Kolkata metropolitan area. So now I am giving a area referencing here, and if I see this is an Kolkata municipal area, again an area referencing. Now in that I have number of wards, so this is wards referencing, and each ward has a pin code. Okay, so each pin code is nothing but again a pin code referencing. So this is nothing but a discrete. I have just given several examples so that everyone understand how geocoding is normally done in terms of using a GIS. So this is all for the grids and maps. You can see there are number of grids here. I'll also tell you how these grids are located, what are different ways, and what is, for example, if there is 79A/4, what it actually represents, in what kind of units it represents, and what is the amount of information that it stores about the earth's surface in this particular grid. I'll take this up when I'm explaining the map systems and the IAC systems in my next class. Okay, so when we look at this, the first thing that we looked at is we have elevation georeferencing, which is called as geoids. We have a relative georeferencing, where an offset measurement along the road we looked at. So most importantly, please remember that geoids are the representation of the earth's surface on the mean sea level. Otherwise, you can just say that the mean sea level is represented as a geoid, but maintaining the same gravitational potential across all continents or across the entire land surface of the earth. So that is nothing but a geoid. And when you look at polar georeferencing, we did see we take a reference, normally a north pole as a reference, then we calculate what is the distance from the north pole or the directions from the north pole with an angle. So that is called as a polar georeferencing. Then we looked at different direct discrete georeferencing systems, and importantly the mailing address. And when we looked at the mailing address, we understood it is more of a hierarchical based approach. When I say hierarchical based approach, it starts from the bottom of the table and goes up to the top of the table. Okay, so when we actually look at the entire mailing address, for example, if you look at any of the mailing address for the entire region of the land surface or the globe, so it is extremely discrete for that particular region. So you won't have the same mailing address to any part of the earth's surface. Then that's why it's called a discrete system, and there is only one assigned code for a particular thing. Okay, so if you want to try how discrete and how it can be easily accessed, I would suggest write a particular postal form, and maybe you can post it with just your name and your pin code. So that post will surely come back to you because you have mentioned the pin code and your name. So if you are a well-known person in that particular locality and a postman knows you, it's easier, okay, for them to locate you. But other information, in case they don't know you, they may need your area and other signatures in your postal code. So in the next session, the next part of what has to be understood, that is the coordinate system. So now we have understood what is a geoid. We looked at elevation referencing. Next is the coordinate referencing. So once we have understood how the earth surface is, what is the reference system for the earth surface, that's a geoid. Now we move into the next part wherein we look at the coordinates. Once we look at the coordinates, which means you are plugging in the entire system onto the earth surface, then we look at the projection. So we bring the 3D map to the 2D surface. We already know how we are plugged in, so put it tie it onto the earth surface. So that's how you tie the entire 3D surface to the 2D map. So in the next class we look at the coordinate systems, how to apply it, how to use it, and what are the different ways of looking at it. Okay, thank you very much. Let's meet in the next class.